I'm ready, bro. Send me the link. Scared, bro. Can you like calm me down before we start? I'm nervous. I haven't coded ever since I failed my last Citadel interview. I was depressed. I stopped eating. I stopped drinking. I lost my wife, my job. It's just been really bad, bro.
A few nights ago, Frying Pan like called me like 3 a.m. in the middle of the night. He like failed his Citadel interview. He begged me to like give him a mock interview and like help him out so he doesn't keep failing. So that's what we're doing here.
That is exactly what happened.
And he's never gonna fail again after today.
All right, bro. If I fail tomorrow, there will be consequences. Hello, I am in the dock, Mr. Neat.
So I'm just gonna like give the background to like everybody who's watching how these like interviews work.
I'm a professional. I already know that.
I'm gonna do a mock coding interview with Frying Pan. This is gonna be similar to how a real Google coding interview is. I work at Google. I've done over a dozen interviews now over there. First, I'm just gonna like introduce myself and then like ask Frying Pan to like tell him about himself. The interview is gonna go about 40 minutes, maybe 45 minutes, and then afterwards, I'm going to do the debrief, which is basically tell him how he did and how I would have rated him if this was like a real interview. I'm pretty much just going to use like a real LeetCode question. This isn't a real Google question for the people asking. At any point, if you get stuck, you can just look at my face to like look at my facial expression.
Where is your face?
Okay, let's get started.
Face reveal. I'm sorry.
I'm going to start the timer right now.
Okay.
This is the question. I want you to design a class.
Pause. Before this interview starts, I'd like to ask you a question. Would you like to keep your Google searches private for when you're searching for stupid questions so no one finds out? Who knows? Google might interview you, just like me, if you're smart enough. Like me. Don't you hate it when you click on a link looking for documentation and it turns out it's a malicious link and now your entire computer is hacked and you lose your unsaved code because you didn't know how to use Git? Atlas VPN is exactly what you need to provide you with the privacy and protection that you need. And you can get this most affordable VPN on its Black Friday deal right now. With Atlas VPN, I never have to worry about people stealing my data or copying my spaghetti code again. It is truly wonderful and you can even use it on multiple devices with only one subscription. You can even watch your favorite show no matter where you are in the world with a simple click, whether it's on mobile phone or computer. So make sure you check out the Black Friday deal now so you can get Atlas VPN Premium for just $1.7 a month plus 6 months extra and 30 days money back guarantee. It's the best deal of the year, so please click the link in the description below. It's a limited time offer. Thank you very much.
That supports these 3 operations: inserting a value, removing a value from this class. Where it gets interesting is I want you to be able to get a random value.
So let me just repeat the question back to you to make sure I understood it. I have to create a class that essentially has 3 functions. One is to insert an element, second one is to remove an element, and the third one is to get a random value that is currently in the class. Is that correct?
Yep, that's exactly right.
Are these values like integers or strings, animals? Like, are they specific something?
Yeah, you can assume that they're integers.
So then let me ask you this question. Are there going to be a lot of elements we're inserting? Is it just going to be a certain amount?
You can assume that it's like a reasonable amount, maybe like in the terms of millions. You shouldn't run into like any limitations like with memory or anything like that.
Okay. I'm going to ask you one final question before I start coding. Can I code in Python?
Sure.
Here we go. First thing I'm going to do is create a class store. We're going to start with the constructor. Is there a way to turn off this auto capitalization, sir? This is really annoying
me. You can just ignore it. Yeah, you can just pretend. We can ignore the capitalization. You can just assume that it's correct.
Hey, try to ignore it. I'm just going to say it's not very inclusive of you because I have OCD and this is pissing me off. Constructor init. Here we go. What are the variables we need here? We are inserting values and removing values, so we need a data structure to store these things. So let's think about what we actually can use for this. We can either use an array. So if we use an array, inserting, removing, will be O of 1 on average. Since we're inserting a lot of elements, okay, we'll have to keep growing in size. It might be useful for the get random since we have an index. Let me just think about this for 5 seconds. If we use an array to insert these values and we don't want duplicates, so let's say we just use an array and we insert values, removing a value would be O of n since we have to find the actual value. Let's say we use a hash map to insert these values. We can make sure that there are no duplicates, and we can make sure that inserting and removing is on average very fast, O of 1.
Yeah, that sounds good to me.
The third thing we have to consider is we need to get a random value out of everything that is inserted. How to get a random value with equal probability.
Yeah, when it comes to getting random, I'll actually help you out here. You can assume that there is a method, let's call it random.choice, I think in Python, and it takes some list of values and it'll return you a random number with equal probability from that list.
I actually already knew that, but thank you very much for the reminder. So let me just start by initializing a hash map. Map equals to inserting values. So the next function will be insert. Def insert. For the parameter, it will just be a value, right? We're passing one value to this function. I think we can just insert it directly like this. Value inside of it. For the input, is it just one value or is this something else during the insertion?
Yeah, you can just assume that it's an integer.
Okay, then I think what we can just do is add this value to the set. And then for the remove, you can just remove value from set. Move value. So these will be a very quick operation. No duplicates. I think this is fine since it's a set. So if there's already one, it will just replace it or not put it in. And then for the get random, if there's a function that you can just get something from a list randomly, I guess the easiest way is to just convert this set into a list and use this function on it. Return random.choice list self.map. Yeah, let me put this here since these are class functions. We can also add some checks for this set, like to see if it's like empty or not before removing, or to see if this map exists. But I think that's fine since by initializing this class, this map will exist. Yeah, this will be O of 1 insertion, O of 1 remove, and this will be O of n for the get random.
Yeah, that's correct. So this definitely works. Is it possible to get the get random function to be a bit more efficient?
This random.choice is O of n, correct? Like it has to iterate through the entire list to give an answer.
Let's assume that the random is actually constant time, where your function is becoming linear time is converting the entire set to a list.
I see. Okay. Since the conversion cannot be avoided if we use a set, I'm assuming for this to store these values, we probably have to use an array. The problem with using an array is the removal will be not efficient anymore. Is that an issue? Or do we want all these functions to be O of 1? Is that what we want?
Yeah, that's a good point, because if we do it the way you kind of proposed, we can get the get random to be more efficient, but remove will then be linear time. So we don't really improve anything, assuming that each of these is called like an equal amount of times, which you clarified. So yeah, you're on the right track. Is it possible that we can get all three of these to be constant time?
I think we probably have to use a combination of data structure here. So let's say we have a hash map that stores the index of each value. When we remove, we can just remove it from the hash map and take a note there. And then we know that it's not in the array anymore, even though it's like technically still there. Then we can fix the problem of removal being slower. So then removal and insertion will both be on average O of 1. But then for the get random, there will be integers in the list that are not supposed to be in there. How do we make sure that those integers are not taken into account? What if every time we have a value we want to remove, and we know where it is in the array, right? So let's say we switch the place of this element to the beginning of the array, to the first element that is still supposed to be inside this array. So then we can essentially separate all the values that are technically not supposed to be in the array. Once we have all of this separated, we can do from there till the end, use the random choice on those. But then we still have to slice the array. So that's still kind of O of n. It's like a bit better.
Yeah, I think you're definitely on the right track. I guess I have a question. So you said earlier that the problem is we can't remove a value from an array in constant time.
Yeah.
Why is that the case?
Because it could be but on average, it will not be constant time, since if it's in the middle of the array, we have to move all the elements at the end and like push them back.
Yeah, that's true. Is there any case where removing from an array actually is constant time?
Oh, if it's at the end of the array, it'll be constant time. If we do that, and at every time we remove something, we switch it with the end of the array, and then we remove it, that will be O of 1. And then we can just use the random.choice on the original list because they won't have all the values. Okay, I will start coding now. So the first thing is we'll initialize a array. We'll call this values, and it's going to be an array. We're also going to use a hash map to store the index of where each value is. So now let's go for insertion. How will insertion work here? I think the first thing we need to do is check if it's already in there. If the value is in self.map, then we want to return, since we don't want any duplicate. Is this the correct behavior we want? If there's a duplicate, we just do not insert the new value.
Yeah, that works.
Okay. Once we have this, I think we can just perform the insertion. So self.values, we can append value. Now, how do we know what index this is? Because we have to put this in a map. So the value of this will be equal to the index. So this index will be, I think, the length of this array, since it's the last element. Length of self.values minus 1. I think this is correct for now. Value in self.map, if it's already in there, we return. Otherwise, we append it to the values array and we store at what index this value is. Let's go to the remove function. We first want to check if it's in the map at all. So if value is in self.map, if it's not in the self.map, we can simply return. Now, if it is in, that means it's an accurate value that's also in the array. And then we want to remove that. We can find at which index this value is by using the map, the self.map value, to get the index of where this value is inside of the actual array. Here is where we need to perform the swapping. Okay, so I think we just move it to the last element. And to do this, let's save the last element. Last value is going to equal to self.values minus 1. We can put this new value at that place. Self.values equals to self.values minus 1. And we want to put this one back. Self.map last value is going to equal to index. Okay, let me just make sure the swapping makes sense. I'm getting the last element from this array, saving it, and then adding this new value. I need to add it to the last index. I'm adding the value that I want to remove to the last index of the values, and then I'm putting the previous last value at the index of the other element I'm trying to remove. Okay, and then at the very end of this, we can then remove said value we want to remove. I think we can use delete. I don't know if delete is the correct keyword. Inside of the getrandom function, we can just simply do random choice self.values. Does this make sense?
Yeah, this makes sense. So a quick correction, actually, for the list itself, you can just use pop.
True. Okay, so I'm missing something here is we need to also update the map. So in order to update the map, we're going to do delete self.map value. And this deletes it from the map. Okay, so let me just make sure in the insertion, we're appending to the values and we're also updating the map. And in the remove, we're also updating the values array and also updating the map.
Do you want to walk through a couple like test cases?
Yeah, for sure. Okay, let's just say we insert 3, 4, 4, and then 5, and then we remove 3, and then we get random. And obviously we first initialize the class. Let me write down self.values is this, self.map is equals. To keep track of the values, first we insert 3. And in the insertion, a value in self.map, it's not in the map. It's going to append to the values array. So we have 3. And then it's going to put it in the map. So in the map, we're going to have 3 with index 0. After this, we're going to insert 4. It's going to be the same thing. So append value 4 to the value array, put it in the map. So 4 with index length of self.values, it's 2 minus 1 is 1. So here we go. Then we insert 4 again. It's already in it. We just return. Then we insert 5. Same thing. It's going to append 5 to this, and self.5 is going to be 2. And at this point, we want to delete 3. Going into the remove function, we can see that 3 is inside of it. So now we get the index of 3, which is x equals to 0. And then the last value is equal to 5. Self.values minus 1 is going to equal to the value. So here we're going to update 5 to value we want to delete, which is 3. And then self.map last value equals to, so we need to also re-put the first element that we deleted back inside. So self.values at index is going to equal to last value. This index is 0, and we're going to replace 3 with 5, which is the last value's value. At this point, we're updating the map, self.map last value, which is 5. We're updating the index back to 0. We pop from the last array, so it's only 5, 4 now, and we also delete 3 from the map. Okay. And at this point, we get something random, and it's gonna get something random from 5 or 4. There we go.
Yeah, perfect.
We got it?
Yeah, I mean, that was a good catch.
Let's go.
So I have a question, a couple of questions. So this solution works perfectly if we don't allow any duplicates. But what would happen if we did allow duplicates? Like we could have multiple 3s, multiple 4s. And in that case, the probability would still be the same, actually. We would still want the random to be proportional to how many times each value has been inserted. So we don't have to change the get random, but how would you change the rest of this code to allow for duplicate values?
If that's a scenario, that means the 4 here that we implement, so there's going to be 2 4s in the array, correct? In this example I have down here.
Yep.
That wouldn't work with the current one because in the hash map, I cannot have duplicates. What comes to mind is instead of associating each value with just one value, one index. If I use an array, I can store multiple indices. So if I have a 4, I can have a 4 at index 1, I can have a 4 at another index. In that case, the remove can just delete any of these 4s, right? It can be the first 4 or the second 4 or the third 4. It doesn't really matter. I think that's pretty much it. I can just replace the 1 with an array to keep track of the duplicates. So
yeah, that's exactly correct.
Yeah. So in the insertion, I would obviously check if it's already in the self map. I would append to the array. Does that make sense?
That sounds good. We can code that up.
Oh, okay. We code that up. All right. I thought we were just talking. In the insertion, we're gonna start here. If value is in self map, return. So obviously we're gonna change this. Okay, so instead of using a initializing like this here, I'm gonna use collections.defaultDict, and I'm gonna put a list in here so I can just append directly to an empty list for every value. So if the value is already in the self map, I'm just gonna do self map value dot append length of self dot value -1, and also obviously append this to the values array. Boom. Actually, we don't even need this. We can just do this. We're just going to directly append it to a value in the map. If it doesn't exist, it's going to be an empty list. This is going to be the first element associated with it. If it does exist, it's going to be the same thing and append it to the value array. This works for the insert. Now for the removal, if the value is not in self map, we have to change something regarding this swapping, because now what we're returning is an array. Self-map.value. So we're just going to return the first index and we're going to delete this first index. The first index of this value, whether it's duplicate or not. We just have to change the map. So the map last value equals index. We're going to do append instead of equal. Okay, so in the delete here, we have to change it. So self.map value, this is going to be an array. We don't want to delete this entire array. What we need to do is delete the specific index inside of this array. Something we can do to make this better is use a set instead of a list. So I'll just use a set here. Since order doesn't matter here, I'll just use a set and it'll be faster for insertion and deletes. So self.values append. So we're going to do add. Here we're going to do add self.map.value. We're going to remove this index. Move index. I think this works. Do you want me to run this through an example again?
Sure. Yeah, let's go ahead and do the same example that you had before.
Perfect. Okay. So self.values, we do an insertion. We're gonna go quicker here. We add into the map first. So the map will have value 3 with a set of, it'll be 0 for its index. And then in the values array, we're gonna just append 3. So no problem. And then we're gonna do it the same for 4. 4 is gonna be this. And then after this, we're gonna add another 4. It's gonna go self.map value, add to this. So 4 is gonna add 2 here. Okay, actually, I have to do this append before adding it to the map so that the length is accurate. So now that we have everything in the values array and the map, yeah, we have the duplicates, and then we add 5. 5 is going to be here. Okay, instead of deleting 3, we're going to delete 4 here to see how it works, because deleting 3 will be, I think, pretty trivial. So deleting 4 will be the one that's has a duplicate. If value is not in self.map, it is in. So index is equal to self.map value 0. So 0 here, I cannot use 0 here. How to get the first element? How do I get one element out of a set? Yeah, maybe I do need to use a list.
I think we can just assume that there is a way to remove it, because I think otherwise
I got it, sir. I got it. We can use dot iterator parentheses dot next to get the first element of the set. Now,
yeah, that's great.
Yes, bet you didn't know that. Now we're gonna do swapping. Index is gonna equal to the first element, which is 1. Last underscore value is gonna be equal to the last value of this array, which is 5. We're gonna do self.value index, which is 1, equals to last value. So self.values index is, the first 4 is gonna equal to 5. And then self.map last value is 5. So this one, we're gonna add this index. So we have to add 1 here, but we need to delete the previous one. We also need to do self.map last value. Remove length of self.values minus 1. So yeah, so this is 3. So we remove 3. And then we pop from the value. So we pop, wait. Self.values index, which is 3. Okay, I don't think I did this line. So self.values index, which index is 3, is 1. Wait, I think there's a problem here. So index here is 1. Self.values, the last element is value. Okay, I forgot to do this. So 5 is going to be equal to 4 here at the end. So then once we pop, we're going to pop 4 from this, and then we're going to remove this value, which is 4 we removed. We're going to remove the index which was 1 here. We're going to remove 1 from this, and we're done. Please tell me there's no more follow-ups.
We have like 4 minutes left, but I think this code looks good.
Yes!
Do you have anything else you wanted to change?
Fuck no. No, I'm kidding. But I think, let me add another follow-up. Let me ask you a question. Is this code thread safe?
Probably not.
Correct. In order to make this code thread safe, we need to add locks for the insert and the remove and the getrandom. And that will be all. Thank you very much. Did I get the job?
Yeah, so we finished with 4 minutes remaining. Let's do the debrief now. I wasn't taking notes, actually. Usually in like a real interview, your interviewer will take notes. So first, like I gave Pan the question. It was really open-ended. I just said like insert a value, remove a value, and get a random value. And he clarified that these are like, what are we inserting? And I said numbers, like integers specifically. That was good by him. I forgot what exactly his clarifying questions were. I think it could have been like slightly better, talking about like the edge cases of like, what if we don't have any values that we can remove? Well, he handled that in his code. But what about if we don't have any values that we can get a random value from? The way we coded it, we assumed that there's always going to be some values inserted, which is the case, but that was more of like an assumption that he made, but he didn't specifically clarify that. I think it worked out. As he was coding, when he finished, he talked about like the time complexity without being prompted to. Like before he even coded, he was talking about ways to make it more efficient. I think that's good because you could easily go down like the wrong track with these problems. And if you go too deep without asking any clarifying questions, you might have to like restart your entire solution, which will waste a lot of time. Running through like the test case, he did really good, I think, on just like keeping track of everything, just like explicitly writing it down. When I say like do a test case, like in real interviews, people will actually mess it up a lot. Like they just lose track of what they're doing. And sometimes I'll even lose track. Like I don't even know what they're like saying anymore. So I think Pan did a good job of making it pretty obvious to me what he was thinking about the entire time, like what was going well, what the time complexity was, what data structures he was planning on using. And like you got the correct solution for the first question and the follow-up. I guess you needed like a few hints, but the fact that like the solution is correct, I'll give like a binary decision of whether I would like lean towards no higher or higher. And I would say for this problem, I would definitely give you a higher. So,
Let's go.
yeah.
We passed. We passed. Keep
But I
going.
guess Citadel thought otherwise.
Wow, you had to add it in there. What the fuck?
Too soon, sorry.
What the
Okay, I have a question for you. In your real interviews, do you talk the same way?
No, of course not, bro. Wait, what's wrong with how I talked?
No, I mean, like, nothing. It was good.
Wait, what? Wait, I talk similarly to this in my interview. Is that bad?
No, I mean, like 99% of it was fine. But like there was parts where I can't tell right now, but I thought you were joking.
Okay.
Okay,
Noted.
moving on.
Now it's my turn to interview you, Nicole. I have a hard DP question for you.
That's gonna be on next time.
That would be next time. By the way, bro, what do you think about this Twitter thing?
Elon Musk.
Yeah.